For number 6, we need to simplify this. What is a number that will go into 6 and also into 24? Braden. 3. I can divide both of these by 3. We could have also used 2. If you want to use 2, you can use 2. Braden said 3, so I'm going to use the one that she said. Dividing by 3. 6 divided by 3 is 2. And 24 divided by 3 is 8. If you use 2, you would get a different fraction here. If you divided by 2 the first time, now you're going to divide by 3. We divided by 3, so now what can I divide by? 2. Do y'all see how those kind of flip-flop? All right, so now we're going to divide these by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. Kind of gave that one away, sorry. All right, so I get 1/4 here. Number 7, Easton, what do we want to do first? The first one, what's your question? We also could have used 6 to start with and gotten the answer right away. Okay. All right, number 7, what can I do on number 7? Peyton? It's an improper fraction, so I have 2 choices here. I can try to simplify, or I can go ahead and change this. What do we want to do? Change it. Go ahead and change it. All right. So whatever is down on the bottom is what we're going to put at the door. And I'm dividing that into 44. How many times can 10 go into 44? Jeremy? 4 times. 4 times 10 is 40. When I subtract, I get 4. Now, if we were making this a decimal, I would add a dot and a 0. Am I making this a decimal? No, we're just making it a fraction still. So my big number is 4. How much was left over? 4, so that goes on the top. And what's going to go on the bottom? 10 still. Okay, can I keep going, Jakaria?
Yes, but I'm not, number 6. Can we have done divided by 6?
Yes, we could have just divided by 6 on number 6. All right, you still got 1/4, right? It's okay. It's okay. When we get into the zone doing our math, sometimes we don't hear other people's thoughts. All right. Keegan, now what can I do? Okay.
I just took 4 over 2 and I divided it by 2 and got 22 over 5 and then I just made.
And then you did this part?
5 divided 40, 22 4 times and then I split the 2 on 1.
Okay, perfect. So you got 4 still as your big number. You just have a different fraction. So we need our fraction to match Keegan's fraction. What do I need to do still to this fraction? What do I need to do to this fraction still? 4 and 10. Noah? Divide it by what number? 2. Okay, my big 4 is still going to stay 4. 4 divided by 2 is 2, and 10 divided by 2 is 5. So now our answer matches, right? All right. What Keegan did is he divided his by 2 first, then he figured out how many times the bottom number were going to the top. So he did his the opposite. We still get the same answer. All right, number 8. What can I do to number 8? Number 8, Jeremy? I can make it a mixed number. On this one, what I would probably do is, since they end in 5, what do I know can go into them? 5, 15, and 45 are bigger numbers, so I'm going to make them smaller to make the problem easier. Can we do that? So let's divide this by 5 to make my work a little bit easier. 45 divided by 5 is? 9. 15 divided by 5 is? 3. Okay. We could move it over? Yes, that better? Okay, thank you, Mary-Web. Let me know if I go off the screen. All right, now what do we want to do? We have a couple of options. We can do that again, or I can try changing it to a mixed number. What do we want to do, Noah? Let's do it again. What number can go into both of these? 3. So I get 3 and 3. So 9 divided by 3 is 3. And 3 divided by 3 is 1. Can I get any smaller than 3 and 1? No, that is it. So, but it's still improper. So guys, I'm going to ask you a real simple question. How many times will 1 go into 3? 3 times? Are there going to be any left over? So my answer is 3. Keegan? Did you get 3 as your answer? Then you're good to go. All right. We could have at any point in here said 3 will go into 9 3 times. I could have said 15 will go into 45 3 times. Any of those would have worked, okay? I just like doing small numbers because small numbers are easy for me to do in my head. Okay? Are there any questions about Math Workshop? All right. I'm going to pass out our notes for today. We're going to start by just copying down definitions. All right? So if you will, put your Math Workshop away. And we're going to copy down some definitions. All right, moving it down. Please, if I moved it too much, please just raise your hand. So factors is still at the top. Thank you, Mason, for reminding me to record. All right, so as we said, factors is another definition for a word we've done. Prime factorization is where we're finding the prime factors using factor trees, which is that fancy example that we have over on the side. Greatest common factor, that's what we're going to do today. Today we're going to learn about the GCF. Our GCF, G stands for greatest. Does it make sense that the greatest means the largest?
Yes.
All right, common means that they share it. Like if you have something in common with somebody, it means you both have it, right? So our greatest is the largest. Common means they share it. They both have it. And factor is just the numbers that multiply to equal it. Okay? So we want to know the biggest number that will go into both of them without a remainder. And then the least common multiple, we're going to talk about this on Monday. All right? Just a reminder, your test on Wednesday will be vocabulary, GCF, and LCM. Vocabulary is a third of the test. Vocabulary is 33% of your test Wednesday. Okay? All right, if you'll look over on the other side of your paper, we're going to look at some examples. When I'm working the examples today, I'm going to use 2 different colored highlighters to help you see where my work is. So if you would like to get 2 colors out, you may. You do not have to. I'll also show you how to do it with a pencil, okay? But if you'd like to have your 2 colors, I'm going to use that to separate my work. All right, we're going to be finding the greatest common factor on here. It says method 1. What I have discovered today and completely changed my way of teaching since first period is this method 1. We're just going to kind of throw it out the window. I'm not going to worry about method 1. All right, because the great thing is method 2 is guaranteed to always give me a correct answer. So we're just going to focus on method 2. All right, method 2 is using prime factorization, which is one of our vocabulary words that we've just talked about. All right, prime factorization is a really fancy way of saying factor trees. Prime factorization is a really fancy way of saying a factor tree. All right, again, factor trees are something you made a long time ago, but it's been a long time, so we might not remember. So please make sure we write this down that we're doing prime factorization with factor trees. Okay. So to make a factor tree, I'm going to start with the number 14 and 20. I'm going to make one tree for 14, and then I'm going to make another tree for 20. So I'm going to write 14 up here on that very top line. All right, you'll see where I put 14. Make sure you put 14 up as high as possible because we're going to need as much room as we can. Throughout our notes today, you can tell it's kind of squished together to try to save some paper and so we can have our homework on the same page. So try to make sure you line up your numbers where I line mine up so that we'll have enough space. All right, so what we're going to do is we're going to create a tree. 14 is going to be at the top of my tree, so that's why it has that little triangle point to it, okay? So 14 is at the top of my tree. Y'all good with that? Everyone has a little point. All right, what I want you to do is I want you to think about 2 numbers that will multiply to give me 14. It can be any 2 numbers that will multiply to give me 14. Christian? 4 times what? No. 2 times what? 7. So we're going to do 2 times 7. Do we all agree that 2 times 7 gives me 14? All right. The other option, the only other option would be 1 and 14. We don't want to use 1 in our factor tree because we already have a 14 there. If I keep writing 14, it's just going to repeat over and over. So we only want to use other numbers. So with that said, for the number 2, is there any number other than 2 that can multiply to give me a 2? No. So what that means is 2 is done. So you're going to circle it if you're using a pencil. I'm going to go over it in green. So 14 is going to be my green tree. All right, can 7, is there anything besides 7 that can multiply to give me 7? Anything else that can multiply? No. So that one's done as well, so we're going to circle it because it is finished. I'm going to go over it in green so we know that was the end. All right, now we need to do the same thing for 20. So I'm going to put 20, and I'm going to put that at the top of my tree. All right, I need 2 numbers. It can be any 2 numbers that will multiply to give me 20. Any 2 numbers. Braden? 10 and 2. So I'm going to do 10 times 2. You could have also done 4 times 5. That would have been fine, okay? All right, so let's look at 10. Is there anything that can multiply to give me a 10? Jeremy? 5 times what? 2. All right, so that means 10 is going to get to be a branch. So I've got to add more to 10 because it can keep going. So Jeremy said 10 could be 2 times 5. Are y'all okay with where we got 2 times 5? Okay, can 2 keep going at all? No. So if you're using a pencil, you can circle it. I'm going to use a different color highlighter. So 20 is going to be my yellow tree. Okay, can 5 go any further? No, so I can circle it with my pencil. Again, 5 is going to be part of my yellow tree. All right, what about this 2? Could this 2 go any further? No, so that means that's the end of that branch, and that's going to be part of my yellow tree. All right. Now, guys, what we're about to do, you can only use the numbers that are in the circles, okay? So in your circles, for my green tree and my yellow tree, are there any numbers that both of them have, that the green tree has and the yellow tree has? Haley? 2. They both have a 2, right? So I'm going to write a 2 over here, and then I'm going to mark the 2 off of the green tree, and I'm going to mark the 2 off of the yellow tree. Now, do the green tree and the yellow tree have any other numbers that they both share? No. So what that means, guys, is the only number here that's my answer is 2. All right, and that means 2 is the biggest number that will go into 14 and also into 20. Can y'all think of a bigger number than 2 that will go into 14 and into 20? 7 will go into 14, but can 7 go into 20? Not without a remainder. Mason? 5 can go into 20, but can 5 go into 14? Not without a remainder. 2 is the biggest one possible. All right? So let's look at 16 and 42. So again, I'm going to put it on the line up above to give myself some space. So 16 and 42. Okay? So let's start with 16. Give me 2 numbers that can multiply to give me 16. Any 2 numbers. RJ? 8 times 2. I like that one. So we're going to do 8 times 2. I could have also done 4 times 4. Doesn't matter. All right, so I'm going to focus on my 8 because that's the first number. Can 8 multiply to give me anything else? Peyton? Or what? I'm sorry. What else can multiply to give me 8? 2 times 4. I'm going to do 2 times 4. Okay. Can 2 go any further? No, so that one's going to get circled. Can 4 go any further? Yeah, what's that going to give me, Jeremy? 2 times 2. And you can see I'm kind of squeezing them in now. All right, can 2 go any further?
No.
That 2 go any further? What about the 2 that was up here? So back by the 8, it was 8 times 2. Can that 2 go any further? No. So the numbers that can't go any further are going to get circled. And I'm going to go over those. That's going to be my first tree, so I'm going to do that in green. All right, again, you don't have to use highlighters. This is just to help me in my notes so I know what's happening. All right, we need to do 42. So 42, there it is at the top of the tree. Give me 2 numbers that will multiply to give me 42. Think about those multiplication facts that we've been practicing since the beginning. Mary Webb?
6 times 7.
6 times 7. Excellent job. 6 times 7. Okay? Can 6 keep going?
Yeah.
Yeah, so let's keep going. What can multiply to give me 6, Easton? 2 times 3. And Easton, can 2 keep going? No, so I can circle it. Can 3 keep going? No. All right, and then I need to go back up to 7 and check it. Can 7 keep going? No. All right, so there is my yellow tree with 2, 3, and 7. All right, what's a number that my yellow and my green have in common? Braden? 2. So I'm going to mark out a 2. All right, guys, I'm marking out a 2 from the green and the yellow, but I'm only writing it down once because I'm only marking out 1, 2. Are y'all okay with that? All right. Are there any other numbers that they have in common? No, on the green I only have 2s. Here in the yellow I have 3 and 7, so they don't have anything else. So my answer is 2. Now to me this one's like kind of tricky. 16 and 42. Wouldn't you think a bigger number than 2 could go in those? They kind of look like it, but according to my math, the biggest number that can go into 16 and into 42 is 2. And I did my math right, so that's right. Okay, so let's do 45 and 30. So I'm going to kind of move this one up in between so I can have some space. Because you see, these trees take a little bit of space up. So 45 and 30. You'll see where I'm writing that? All right, 2 numbers that will multiply to give me 45. 2 numbers that can multiply to give me 45. Are they? 9 times 5. Very good. Okay. 9. Can 9 keep going, Julia? Can anything multiply to give me 9? What numbers can multiply to give me 9? You got this. I'm going to come back to you for another one. Okay, I know it's hard to think of math when you're put on the spot. What can multiply to give me 9, Carrie?
3.
3 times?
3.
3. Okay, can 3 go any further? No, so I'm going to circle it. Can 3 go any further? So I'm going to circle it. Can 5 go any further? So I'm going to circle it. And I'm going to put those in green just so they're easy to see. Again, guys, that's just to make it easy to see. If you want to do that in your homework, you absolutely can. If you want to do it on the test, it's a great technique. All right, what about number 30? What numbers can multiply to give me 30? Braden? 10 times? 3, I like that one. All right, can I split 10 up some more? What else can multiply to give me 10? Carrie?
5 times 2.
5 times 2. All right, can I split 5 up anymore? No, so let's circle it. Can I split 2 up anymore? So let's circle it. Can I split that 3 up anymore? No. So those are going to be my yellow pieces. There's the yellow tree. Okay. Do you see a number that these 2 trees have in common? Braden?
5.
They both have a 5. So we're going to pause there. So let's do 5. I'm going to mark out my green 5 and I'm going to mark out my yellow 5. Okay, now this one's a little different because they also have another number. What else do they both have here, Braden? 3. So I'm going to do times 3. So since I had another one, I'm going to multiply them together. So you see where I put times 3? And then I'm going to mark out a green 3 and a yellow 3. Guys, you notice I'm only marking out 1 3 in green and 1 3 in yellow. Are you all okay with that? All right, guys, do they have anything else in common, though? Now that is going to be it. And what's 3 times 5 going to give me? 15. So this time my answer is 15. So the biggest number that will go into 45 and into 30 is 15. 15 can go into both of those. 15 times 3 is 45, and 15 times 2 is 30. But here's the cool thing. Did you have to know what to multiply 15 by? No, using this technique, it gives me the big number without having to know those big multiplication facts. All right, I'm going to move this down some. I'll make sure I don't go off the screen for me. Is that better? Yes, Christian, what's up? Yeah, we're going to talk about which ones you'll have to do. Okay. All right, so the next one, let's look at 36 and at 54. All right, so I'm going to split up 36. What 2 numbers will multiply to give me 36? Keegan? 8. not 8, but 9 and 4. You can do 9 and 4. That'll work. All right. We could have also done 6 and 6. We could have done 9 and 4, 6 and 6. Is that it? That's all I can think of. We could have done 2. We could have done 12 times 3. Awesome.
6 times 6.
We already said 6 times 6. We also could have done 2 times 18. That's the other one. All right. But 9 and 4 are awesome. So I'm going to split up 9. What can 9 split into? Christian? 3 times 3. Can 3 split anymore? No. So I'm going to circle those 2 3s. What can 4 split into? 2 times 2. All right, and 2 can't split anymore, so those are going to be my green. So I got 3 and 3 and 2 and 2. Okay. Now let's do 54. A little bit bigger here. Jeremy, what 2 numbers can multiply to give me 54? 9 times 6, very good. 9 times 6. 9 can split up. What's 9 going to split up into? RJ? 3 times 3. All right, so 3's done, 3's done. Let's split up 6. What can 6 split up into? Frank? 3 times what? 2. So 3 is done and 2 is done. So there are my yellow trees. Okay. All right, what's one number that the green and the yellow both have? RJ? 3. I'm going to mark out 1 3 in the green, 1 3 in the yellow. What's another number that the green and the yellow both have? Morgan? 2. So I'm going to do times 2. Morgan? So I'm going to mark out a 2 in the green and a 2 in the yellow. Times. All right, and then I need another number that both the green and the yellow still have. Haley? They have another 3. Do y'all see how I still have a 3 there? So I'm going to put another 3 here, and I'm going to mark out 1 more 3 in green and 1 more 3 in yellow. All right, are y'all okay with us having 2 3s here? All right, now the only thing that's left is a 2 and a 3. Do those match? No. All right, so we're going to do 3 times 2 is 6. Times 3 is 18. So my answer for this one is 18. So the biggest number that will go into 36 and into 54 is 18. All right, method 2. We're still using prime factorization, so we're only doing method 2. So there's really not a method 2. We're just going to keep doing the same thing. All right, moving this up some. All right, so for number 5, I have 18 and 30. So I'm just going to do my factor trees off of these 2 numbers. What are 2, Keegan? 2 numbers that'll give me 18 are 9 times 2. Very good. All right, can I split 9 up? Yeah, what's that going to be, Gabby? 3 times 3. All right, 3 won't go any further. Let's circle it. 3 won't go any further. Let's circle it. And 2 won't go any further, so let's circle it. So that's going to be my green tree. All right. Let's look at number 30. Let's split that one up. What can multiply to give me 30? Peyton? 6 times 5 will work. Very good. We could have also done 3 times 10. That would have been another easy one. So 6 times 5. Can 6 split up? Yes. Can 5 split up? So if you want to go and circle 5, you can. Let's split up our 6. What can 6 split into? Kelsey. 3 times 2. Can 3 split anymore? Can 2? All right, so I got a 3, a 2, and a 5. All right, what's something that my green and my yellow both have? Brayden. 3. Times what's something else that my green and my yellow both have? 2. All right, oh. Look, I forgot to put my X's. So I marked out my 3, and let's mark out our 2. All right, can I mark out anything else? Do they have anything else in common? No, all I have is a 3 in green and a 5 in yellow. So my answer here is 6. Okay. All right, let's look at 60. What two numbers can multiply to give me 60? Brayden. 6 times 10. That's where I would have gone. 6 times 10 is real easy off the top of my head. All right. What about 6? What can 6 split into? You could have done 5 times 12. That would be fine. RJ? 3 times 2. 3 is done, so I'm going to circle it. 2 is done, so I'm going to circle it. 10. Keegan? 2 times 5. So I'm going to circle my 2, circle my 5. Can I go any further with anything else here? No. So those are my green numbers. All right. Let's look at 45. I'm going to kind of go to the side on this so I don't run out of space. 45. What two numbers can multiply to give me 45? Jeremy. 9 times 5. Can 5 go any further? No. So I'm going to go ahead and circle it. Let's split 9. 9. What can multiply to give me 9? RJ? 3 times 3. I thought I didn't push record. Just checking. All right, so I'm going to circle my 3s because they can't go any further. And now I'm ready for my yellow tree. Yellow, yellow, yellow. All right, what is a number that they both have in common? Frank? 3. All right, so I'm going to mark out 1, 3. What's another number they have in common? Jeremy? 5. So times 5, and I'm going to mark out a 5. What's another number that they have in common? RJ? Nothing. It was a trick question. I was trying to trip you up. All right, so this one only has 2s. That one has a 3. There's nothing that they both have. All right? Remember, the 2s would have to be in the yellow and the green. All right? So 3 times 5 equals? 15. So the biggest number that will go into 60 and into 45 is 15. All right. Number 24. I'm sorry. Number 7. Am I in the middle up there? Am I good? Okay. 24. What can 24 split into? Keegan? 12 times 2. Can 2 go any further? No, so I'm going to circle it. Can 12 go any further? Yes. What can 12 split into? Morgan? 3 times 4. Oh, I like that one. I would have said 2 times 6. So I like 3 times 4. Pulling it out. Like it. All right. 3 can't go any further, so I circled it. Can 4 go any further?
Yeah.
4? 2 times 2. Can 2 go any further? No. So those are my green ones. So green, 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 green. Okay. 36. 2 numbers that will multiply to give me 36. Gabriella? 12 times 3 will work. RJ, what were you going to say? 6. That's what I've been using today. 6 times 6. So Gabriella, you go on with your 12 times 3. I like it. Okay. Make sure we get the same answer. Okay. If we don't, let me look at your work. All right, I'm going to go with the 6 times 6 because that's the first thing that pops in my head. We could have also done 4 times 9. Those probably were the most popular. All right, so 6 times 6. Let's split our 6. 6 becomes 2 times 3. 2 ends, 3 ends. 6 becomes 2 times 3 again. So there are my yellows. All right, Gabriella, check your bottom. Did you end up with 2 2s and 2 3s on that problem? Then we're good. And she used completely different numbers than I did. Okay? What do my green and my yellow both have, RJ? They both have a 2, so I'm going to mark out 1, 2 in green, 1, 2 in yellow. What do they both have, Brayden?
3.
They both have a 3, so times 3. I'm going to mark out 1, 3 in green, 1, 3 in yellow. What else do they both have, Keegan? They have another 2. So I'm going to do 1, 2 in green, and I still have a 2 in yellow that matches with. Do y'all see how they have to match? All right, is there anything else?
No.
Jeremy?
Another 3.
This one has a 3, but I've already marked out the 3 in green. Okay. So that is going to be all we have. 2 times 3 is? 6 times 2 is? 12. Okay, so I have one more because I realize there's one like it on your homework. Let's add a number 8 down here in the corner. Can y'all see that on the screen? Do I need to move? Am I good? Am I good? Okay. All right, I want to add, let's do 27 and 10. 27 and 10. All right, what numbers can 27 split into? Jeremy?
9 and 3.
9 times 3. Can 3 go any further? No, so we'll circle it. 9. 3 times 3. All right, let's look at 10. What can 10 split into? 5 times 2. Can that go any further? No. So, and I forgot to do my highlighter. I'm sorry. So let me do my green ones. Green. And my yellow ones. Do my green and yellow match at all? Do y'all see anything that they have in common? No, there is nothing in common here. So what is the only number that can go into 27 and also into 10? I want you to think about this. Can you divide something by 0? What's the only number that can go into 27 and also into 10? Gabriella? 1. So if that happens, the only answer I can use is 1, because 1 will go into everything, won't it? So my answer here would be 1. All right, I want us to flip it over onto the back. All right, y'all have done really great. So for my regular classes, what we're going to do is we're going to take this side of our paper and we're going to put a big old X on it. We are going to do the odd numbers. Okay? So go ahead, mark out the right side of your paper. The whole right side. We are going to do only the odd. All right? So for number 1, I have 15 and 105. All right, I'm going to kind of get us started. We'll do 1 together, and then you will have 9 to do tonight, okay? 15. What are 2 numbers that can multiply to give me 15? Jeremy? 3 times 5. Can 3 go any further?
No.
Can 5 go any further? No. And I'm still going to highlight these. All right, 105. This one's a little bit trickier. What is a number I know can go into 105? I know I can use 5, right? So I'm going to do 5 times. If I don't know what to multiply by, what's the opposite of multiplying? Dividing. So I'm going to go over here to the side, and I'm going to do 5 into 105 so I can figure out what to divide by. Can 5 go into 1? Can 5 go into 10? So I get twice. 2 times 5 is 10. When I subtract, I bring down my 5. 5 will go into 5? Once. And 1 times 5 is 5. So what would I be multiplying 5 by? 5 times?
21.
Okay. Can 5 go any further? No. Can 21 go any further?
Yes.
Yes. What's that going to be, Carrie?
7 times 3.
7 times 3. Can 7 go any further?
No.
Can 3?
No.
Okay. So there's my yellows. All right. What is one number that they have in common, Peyton? 3. So I'm going to mark out my 3s. What's another number that they have in common, Gabby?
5.
5. So I'm going to mark out my 5s. All right. Do they have anything else in common?
No.
So what's my answer here, Carrie? 15. The GCF is 15. All right. I want you working the rest of them on your own. If you have questions, please ask.